So in this lesson, we are going to introduce encryption or symmetric encryption. Again, yet another very important topic. In fact, it is fairly straightforward topic as well. Although encryption algorithms are complicated, understanding encryption itself is not very complicated. In fact, we are not going to get into any specific of any particular algorithm, but we'll try to understand as much as possible, just like we did in the case of hashing. Also, we will do some practical with OpenSSL, just like in the case of hashing. Without further introduction, let's get into the topic. So, encryption. Specifically, we are going to discuss something called symmetric encryption. We'll explain what is asymmetric encryption in the later lesson, but in this particular lesson, we are going to look at symmetric encryption. So the idea behind encryption is pretty straightforward. So you have a information in plain text. So it is a secret information you want to give to someone else, and you encrypt. You encrypt that particular information and convert it into something called ciphertext. Ciphertext. So that's what encryption is all about. In this process, normally we use something called a key as well. The size of the key is arbitrary. So what happens inside this box is a process of changing this particular text such that no one can understand the actual information from this ciphertext. But you should be able to decrypt it as well. So in the case of decryption, so you'll be giving this particular text and you run the decryption algorithm, and inside the decryption algorithm you will provide the same key, the exact same key, and you get this particular text right here. So the green part is the encryption and the red part is the decryption. Now the word symmetric is all about this particular key. For encryption as well as decryption, we are using the exact same key. That's the fundamental nature of symmetric encryption. So we'll see other type of encryption, which is asymmetric, in which encryption and decryption is done using different keys, which is the public key for encryption and private key for decryption. But in this case, the same key is used for encryption and decryption. Now, what is this key? Key is just a number, a binary number. Just like this file, another binary, same here, another binary information. All are just numbers. Everything is numbers at the end of the day. Now, this particular box right here can be anything. It can be as simple as an addition operation, just like the case of the modulo operation for hashing. I'm going to give you a fictitious weak encryption algorithm as well, just like the case of modulo operator, just to get a feel of what's happening inside the encryption or decryption block. I'm going to take the example of addition here. Suppose your secret message is, say for example, name Anand. So this is the text you wanted to convert or encrypt using the addition encryption algorithm. So that's what we are going to do. So this is the text we need to encrypt. Now what I'm going to do is to convert this to some numbers, say a equal to 10, n equal to say 11, again 10, 11, and say d equal to 12. So this is the corresponding encoding of the name Anand. Now what I'm going to do is that I'm going to add a pretty big number, pretty big random number to each of these digits right here. So what I'm going to do is I'm going to have a pretty big, say 1000-digit number, 1000-digit random number, pretty extreme, 1000-digit random number. I'm going to add that to 10. I'll get a result. Probably it'll be another 1000-digit. Like that, I'll do for this, this, and this. So I get 5000-digit random numbers after adding these numbers to it. Now I'm going to call it N1, N2, N3, N4, and N5. So why N1 and N3 is not equal? Because this 1000-digit random number is different for different inputs. So there is a new random number for this, another new random number for this. So N1 and N3 is different, although text is exactly same, which is 10 in this case, which is equal to letter A. All right. Same the case of N2 and N4, which is representing 11 and the letter N. So N1 is 1000 digit, N2 is also 1000 digit, and all these numbers are 1000 digits. Pretty big number. Now, these 1000 digit numbers are my keys. So 5000 digit numbers. I'm going to call it the key. And this is my plain text where I want to do the encryption. So I have done the addition operation. And this is my ciphertext. After the addition, I got the ciphertext right here. CP is this. Now, one thing I need to do is to transmit this information secretly. These numbers, which is a key, these 5 numbers, these 5 random numbers right here, the 1000 digit random numbers, has to be communicated to the other end where I'm going to do the decryption. So this 1000 digit random numbers I have given, which is a key, to the other end where I'm going to perform the decryption. So let me draw that in a different color. So this is where the decryption happens. The key is the 5000 digit numbers. Now with that key, I got this particular ciphertext. Now all I need to do is to subtract. So if I subtract the first random 1000 digit, which is the part of the key, so N1 minus the first key number, I'm going to call it, say, key 1 or K1 equal to 10. So this is the decryption algorithm, which is nothing but subtraction. Now think about someone in the middle getting this particular digits right here. It is very difficult to understand anything out of it because it can be any combination. To figure out Anand from this 1000 digit numbers, total we are dealing with 5000 digits, 5000 digit random number. It's very difficult to decrypt that. So there are a lot of problems in this algorithm, but I'm just giving you an example of how encryption works. There are a lot of problems. Although it works, there are a lot of problems out there. As a matter of fact, the problem is not security. The problem is more practicality. Computing 1000 digits, creating 1000 digit random number, and managing. All that kind of problem is there. So we are not going to discuss all those things, right? So we are trying to understand what or how an encryption is done. A symmetric encryption. We are getting a feel of it. In fact, what we have discussed is kind of a modified version of an encryption algorithm called one-time pad. It's a pretty old algorithm. It is not exactly one-time pad, but it's kind of a version of one-time padding. So if you want, you can read about one-time pad, although it is not a frequently used algorithm. And one of the things with this one-time pad is it is an encryption technique that cannot be broken. So one-time pad cannot be broken. It is mathematically proven that one-time pad cannot be broken. It is not that hard to see why it cannot be broken. Even from this particular example, it's pretty clear why it cannot be broken. As you can see, this is pretty much it. Kind of something we've been doing in the example we have seen. Feel free to read about it if you like to know more information about it. Now, a little bit about symmetric encryption in general. So in real world, more efficient algorithms are being used, like DES or most modern AES. We'll see an example of AES. So this is the diagram we have been seeing so far. There's a plain text document and there is encryption, and you get the encrypted ciphertext. And the key is exactly same for encryption and decryption. Now, another thing is, if this cannot be broken, this one-time pad cannot be broken, why do we need another algorithm? The answer is efficiency. This algorithm is not at all efficient. Also, it needs more data transfer. At least in this case, in this example, it is transferring more data as key
the key is much bigger than the data we are encrypting, which is very, very inefficient. And another problem is the compute. The compute requirement could be potentially very high in an operation like this, or to generate something like this. So efficiency, the complexity, both on the CPU and memory is pretty high, even networking to transfer this key. So that's where the modern algorithms comes into the picture, like AES, for example, which we will see. So you can read more about it. Even this page discusses about one-time pad. As long as encryption is concerned, one-time pad is a very important starting step. Symmetric encryption can either use stream ciphers or block ciphers. What does that mean? What is ciphers? Ciphers are just the pet name for the encryption algorithm. So there is two types of encryption algorithm within symmetric encryption, which is stream cipher and block cipher. Stream cipher is continuous. For example, you're seeing a YouTube video. In that YouTube video, the data is being streamed to your system, your phone, or your laptop. It's a continuous stream of data coming from the YouTube server. So in that case, a stream cipher is better. Block cipher is used when you know the amount of data. For example, a big chunk of data you are taking and encrypting and sending. But stream cipher work on continuous streaming of data. They are slightly different in terms of implementation, but just you need to understand that there are two types of symmetric encryption algorithms. AES we will be seeing shortly. In the case of OpenSSL, we'll be using OpenSSL to actually encrypt a file in this particular lesson. This is pretty much used nowadays. Advanced encryption standard, AES. Different versions of AES. So there are other implementation of symmetric encryption, which is used in production. Sometimes these are called cipher suite as well. Cipher suite, which means a suite of different encryption algorithms. So a lot of optimizations are used in these algorithms. For example, DES, data encryption standard, AES. Because of that optimization, these algorithms are prone to attacks. There are different attacks. Non-plain text attack. You can read about these attacks. Different plain text attacks. Chosen plain text attack. Differential cryptanalysis. Linear cryptanalysis. Oracle attack. All these different attacks are possible on these cipher text. But AES is considered to be relatively safer these days. That's why it is being used, at least at the time of this particular presentation. We don't know what happens tomorrow. And AES 256 is believed to be quantum resistant. What does that mean? Is that the quantum cryptography kind of solves the problem of integer factorization. We'll discuss integer factorization in the next lesson when we discuss asymmetric encryption or PKI. But for the time being, AES 256 is pretty secure at the time of this particular presentation. So other than these attacks, the biggest drawback of symmetric encryption is the key transmission. How do you communicate the key? You need to have some other mechanism to transfer the key from one system to the other. So if you go back to the diagram, the actual text you need to transfer is this particular text right here. So let me draw that in a different color. So this is the text you are trying to transfer to the other end, the other party. So for example, this is Alice and this is Bob. So Alice has this particular text right here and she wants to give that text in a safe manner to Bob. So the problem is Alice has to transfer this key somehow so that Bob will make sense of this particular information. Otherwise, Bob cannot decrypt it. So how do you transfer? How Alice can transfer this particular key? She cannot transfer the key along with or using the same mechanism as the ciphertext, because otherwise, whoever has this ciphertext will have the key as well. So Alice has to have some other mechanism. For example, if she's sending this through post, this key she has to transfer it through some email or some other mechanism altogether. It's very important. And in more than often cases, there are no two different mechanisms. In the actual networking world, it is going to be the same exact same network. There won't be email and post in the real world to transfer the key. That is where the real problem of symmetric encryption. And that is exactly the reason why we cannot use symmetric encryption alone in the case of internet. There is no way to transfer the key. And how we are going to solve that problem? That is where the asymmetric encryption is going to come in the picture, or public key encryption, or PKI. And that is what we are going to see next. Before we go there, let's see if we are missing any points in the Wikipedia pages. We'll just skim through a couple of jargons. So we have seen the symmetric key algorithm or symmetric key encryption. So the word cipher, like I said, it is nothing but algorithm, the pet name for algorithm, which converts the plain text to the ciphertext. Another pretty straightforward algorithm is Caesar cipher, not very secure. This kind of diagram shows the nature of some of these new algorithms. How do they mangle the data based on some keys? In fact, all of these algorithms are open source. For example, if you want to get into the AES, it's pretty well documented, although it is outside the scope of this particular training. And before we go, like I was saying, let's do an example in OpenSSL. So we have the OpenSSL installed here in the previous lesson. What I'm going to do is that instead of going to this path all the time, now I have CD'd into this particular path, I'm going to add this particular directory to my path variable so that I can simply type the command OpenSSL. So bear with me for a moment. So let me copy this and to add to the path. So I'm going to the environment variable. If you want, you can do the same thing, but it is not really required. I'm just making my life a little easier. Normally, OpenSSL I use in Linux and not in Windows. Windows I am using just for the purpose of training. I'm adding this path to the path variable. So I'm going to close this and open another command prompt. Let's see if the command OpenSSL works. In this directory, it is now there. I'm expecting it to work from the path variables. OpenSSL. Yep, it is working as expected. So make sure that if you're doing this by yourself, you need to start a new command prompt. So these are the different commands OpenSSL support. Cipher commands. That is what we are interested in for encryption. So there is this AES here. You can see AES 256CBC. There are so many other variants available. All have different properties and use cases. Some of them are broken. Even when we use this AES 256CBC, we'll get some warning. First of all, let's create a file to encrypt. So I'm going to create a file, new text file. You can create any file you want. File to encrypt. So this is the file to encrypt. So we will cd into this folder to make things easier. So the command is OpenSSL, then the cipher suite or the cipher algorithm you need. In this case, I'm going to select AES 256. Then -a. -a is to make sure that the output is base 64 encoded. If you don't know what that means, don't worry about it. I hope I will discuss base 64 encoding in this training. Okay, that brings to my mind while I'm talking about base 64 encoding, although I was not really planning to do that in this particular lesson. There's a slight difference between encoding and encryption. Probably I'll just mention about that as well before I forget. Before that, let me complete this particular command and we'll discuss a little bit about encryption and encoding. A lot of people are confused about encryption and encoding. So -A is making sure that the output is base 64 encoded. For the time being, you can just think of it like you just need a file, the output file, the encrypted file in a particular format so that you can open it in Notepad and things like that. That is -A. Then -salt. This means that whatever text we are giving, the encryption mechanism will add a random number to it to make it more secure. And almost all the algorithm or encryption system uses a salt. This is mainly to prevent some kind of plain text attack. Salt is very effective in countering certain types of attacks because always you are encrypting a random text because you are adding a random output to the whole text. That's where the salt come into the picture to make it more secure. And then -in, the input file, which is the input file, which is the file to encrypt, and -out, encrypted file .txt. Because it is base 64 encoded, you can put it as txt because it's a text file as well. Let's see if it works. I hope I have not made any mistake. So this is where the key comes. Remember the key in the encryption? This is where we mention the key. For encrypting and decrypting, we need to mention the same key. I'm going to key in Anand here, just the name, AND, press enter. Again, it is asking for confirmation, AND, press enter. You can mention any key for the matter. So it is already giving me warning that what you're doing is not very secure. Just give some more options so that it'll do some more things to it. Doesn't matter to us. Let's see what is inside this particular file right here, encrypted file.txt. So this file has created. If you look here, you can see some text here which is base 64 encoded. Now a couple of things we would like to look at is, let me close that notepad. So currently the file to encrypt is empty. Still we got something inside the encrypted file. Interesting. Now let's give something here. This is a secret. So I have saved that file. Now again, we are going to call the same command. And in this case, I'm going to put it encrypted file 1.txt. Again, I'm putting the password, same password, or the key. Now we got encrypted file 1.txt. So what I'm going to do is that I'm going to compare these two files using a text comparison. Compare. As you can see, there is slight similarity. So you can see right here, but then it changes drastically after that. Now what I'm going to do is that I'm going to make a slight modification to the text and see how it looks, just like we did in the case of hashing. So I'm going to modify this file just a little bit. I'm going to add a 1 here, very little. Basically, this is called plain text attack in a particular way, not exactly plain text attack, but that's kind of what we are trying to do. To understand the change, it's more like a differential analysis. What is the change in the ciphertext when we change a small bit of your input text? Differential analysis, small change. It's a very powerful type of attack. So that's what we have done. Let's see if there is any change happening here. So we are going to create 2, again same key, and we are going to compare 1 and 2. The difference between 1 and 2 is just the 1 in the case of plain text. We'll see what's the difference in the case of ciphertext. As you can see, the ciphertext has been drastically changed, except that first initial header. This is completely different, no relation whatsoever. So which means that this encryption is pretty good and it is doing its job when it comes to differential analysis and plain text analysis. Now, next thing we would like to do is to decrypt. The command is exactly the same, just that you need to put a D right here, -D. And we are going to reverse the file. We need to give the ciphertext. Let's give that encrypted text. Probably I'll put the 1. Then out is decrypted file 1.txt. And as expected, it is asking the key, which is the password in this case. I'm going to type the key. All our keys are same. Again, we are getting that warning, and we got the decrypted file.txt. And this is the text we have given. You can try to decrypt the other files as well. It should work exactly as it is. Now, like I mentioned, we'll erase this diagram and discuss a little bit about the difference between encoding and encryption. So encoding is nothing to do much with security per se. Encoding is more of like a convenience thing. It's like a format change. For example, JPEG file, the image files you see, has a file format. Like that, different text file format as well is there. So for example, UTF-8 encoding, Unicode 16 encoding, base64 encoding. So they are kind of a language in which text files are written. So encoding looks encrypted. When you look at the plain text, probably you may not understand a lot. But the thing is that encoding doesn't have any key. So let's draw some diagram. So encoding. So this is the block. So you'll have input text or input information for that matter. It may be text, it may not be text. For example, most of the time when you do base64 encoding, the input is not really text. Input is a binary value. So this is a binary number. What is the difference between binary and text? Binary files you cannot open in Notepad, or when you open in Notepad, it doesn't make any sense. Or a text editor doesn't make any sense to open a binary file in text editors. We have seen all this thing in the Python training. If you want to watch my Python training, I'm explaining all these basics. Feel free to watch. It's a must-watch training for everyone. Now, the base64 encoding, let's say it creates the output text, and this is always a text file if it is base64. You can open this file in Notepad. Now, there is no key involved. Base64 encoding, or any encoding for the matter, doesn't involve any key. There is no secret. So it is a non-way of converting, simple way of converting one format to another. It's a format change, no secret, nothing. But why people are getting confused is because this text in the end looks encrypted. It is just a look of it. Any simple attack, or even people who are experts, they can simply even look at thing and say, what is that encoding? For example, I can see base64 encoding from the look of it. I don't even need to do any analysis. And of course, base64 encoding is well-known encoding, and you know how to decode it. So encryption, on the other hand, has the key here. The key is the main point in the case of encryption. And until and unless you have the key, you cannot decrypt it unless it is a broken algorithm. If the algorithm is broken, that's a different case. Otherwise, you need the key. Now, before we end the session, these days the symmetric encryption is pretty strong, that many cryptanalysis, many law enforcement systems tried for years and years, certain hard disk and things like that. They are not able to decrypt AES encryption without the key. So AES is pretty strong, at least as of now, in the latest form. And that is what we use on a daily basis. Mostly AES we use on a daily basis for SSL and phone communication and different types of communication. So symmetric encryption is pretty strong. Only the problem is the key management. And that's what we are going to discuss next. How do we gonna transfer the key using asymmetric encryption?
So we have seen what is encryption and how that is done using OpenSSL. First, we have seen the concepts and we implemented using OpenSSL. Also, we have seen the difference between encoding and encryption. They are two different things. Sometimes people use it synonymously. That's why I differentiated it here. We'll see a lot of application of encryption going forward, but otherwise we are good to go, and see you in the next lesson. Thank you for watching.